Okay. So in last class, what we have done, we have basically electron and some X-ray is going to interact with this electron. What will happen? This electron will recoil with some momentum P, and this X-ray will change its wavelength, and just it has less energy than incoming wavelength. Let's say this is my lambda incoming wavelength, and this is my lambda dash, and we have two angle. This angle is basically a scattered angle or a scattering angle, and theta is basically known as recoil angle. The phi is the angle at which this particular radiation is going to scattered. Incoming radiation is just going to scattered with different energy because this lambda is different, and the rest of energy, the change in the energy of this wave and this wave or this photon to this photon will be given to the kinetic energy, this particular momentum. And what we have done, we have basically figure out the value of lambda, and the value of lambda is equal to h upon m naught c, and that is 1 minus cos phi. And what is this lambda, delta lambda? This delta lambda is nothing but a change in wavelength. So this change in wavelength is lambda dash minus lambda, and that is h upon m naught c, and this is 1 minus cos phi. So we have derived this particular thing, and we can also calculate the value of h upon m naught c. So what is the value of h upon m naught c? Anybody calculated it?
Is 2.4 into 10 to the minus 12 meter.
Very good. So that is 2.4 into 10 to the power minus 12 meter, and that is known as what? Characteristic wavelength. Okay. So this is basically characteristic wavelength, and we can write our wavelength in term of h upon m naught c. And what is m naught c? M naught c is nothing but rest mass of electron. So you can always remember this particular thing. So this m naught is basically rest mass of electron. Okay.
Yes, sir.
Rest mass of electron. And very interesting thing is that what will be kinetic energy of recoil electron? We have already calculated the kinetic energy of recoil electron is all about hc upon lambda minus hc upon lambda dash. So this is the incoming energy, this is the scattered energy, hence, and the difference between this energy will given to the electron, and which will be the kinetic energy of recoil electron. Okay, recoil electron. This is kinetic energy of recoil electron. So this is the story we have created in our last class, and now we have to apply this thing on some basic problems. Okay, yahan tak clear hai?
Yes, sir.
Okay, so let's try to go for some basic problem. Now my first problem is that if lambda is incoming, प्लीज अपना म्यूट कर लो, है ना, जब आपको बात करना होगा तो अनम्यूट करना, ठीक है, अदरवाइज नॉइज विल बी देयर, है ना. ओके, सो इफ लैम्डा इज इनकमिंग wavelength of X-ray and phi is scattering angle, then find the recoil angle of electron. Find the recoil angle of electron. So phi is given and incoming wavelength lambda is given. Then we have to calculate what is the value of recoil angle electron. So recoil angle is what? Basically theta. We have to calculate theta. So how we will calculate it? How you will calculate it? Is that there is any relationship between phi and theta? Let us try to go for this. Let us try to calculate this one. So you people remember the last class derivation? So why I have told you that derivation is very important, है ना? So what is derivation? We have done the conservation of linear momentum in x direction as well as conservation of linear momentum in y direction. So what is conservation of linear momentum in x direction? hc upon lambda. This is incoming moment. Sorry. What will be in incoming momentum? Can anybody tell me?
Nu by C.
H nu upon c. So we will put lambda later. So that is what h nu upon c. And this value is equal to h nu dash upon c cos phi plus p cos theta. Isn't it? In last class we have done this thing. ऐसा किया था ना? You can do this
sir.
thing in term of lambda also. So c upon nu is equal to lambda. So you can write it in term of lambda. So I am using just the same expression whatever we have done into last class. And now this can be written as h nu upon c minus h nu dash upon c cos phi is equal to p cos theta. We can write it. And what is theta? What is theta?
Recoil angle.
Recoil angle. Theta is nothing but what? Recoil angle. Okay. And what about y direction momentum? 0 is equal to, there is not any y direction momentum, initial momentum. I can assume this is my x direction. So 0 is equal to h nu dash upon c sin phi minus p cos theta. And now look at, we are just doing one trick. Please म्यूट करके रखो.
वो
हाँ,
sin
साइन
theta
थीटा,
होगा।
साइन थीटा होगा, लेकिन प्लीज म्यूट करके रखो. मेरे कान में काफी आवाज आ रही है हॉर्न की. किसी का घर लगता है बिल्कुल ही रोड के पास है ना? म्यूट करके रखो. ओके, जब जरूरत हो तो आप अनम्यूट करके बात कर लेना. ओके, डोंट वरी, अदरवाइज इट विल वेरी डिस्टर्बिंग फॉर मी. सो कैन आई टेक इट इन दिस साइड? कर सकते क्या? We can write h nu dash upon c, that is sin phi is equal to what? P sin theta. So this is my equation 1 and this is my equation 2. You can use it as a formula or you can use it as a problem. आप दोनों में ही इसका यूज कर सकते हो. Okay. Now what will happen if I am just going to divide? So here P is unnecessary there. In the problem, nu is there, phi is there. Can we calculate nu dash? Can we calculate nu dash? Calculate
Yes, sir.
कर सकते हैं nu dash को? Yes, we can calculate. Or lambda dash. Both are same thing. Anyway, first what we will do, you will just divide equation 2 by equation 1. Equation 2 को equation 1 से divide करोगे, then what you will get? You will get h nu dash upon h nu dash sin phi upon c is equal to h nu upon c h nu dash upon c cos phi is equal to what? Tan theta. Isn't it? And now what we are doing, we are just dividing by h nu dash on both sides. So what will happen? So we can get sin phi by, and if you are dividing it, that value is what? Nu upon nu dash minus cos phi is equal to tan theta. And in term of lambda, how you can write it? You can write this particular thing sin phi by lambda dash upon lambda minus cos phi is equal to tan theta. Now can I write lambda dash is equal to lambda plus delta lambda? लिख सकते हैं ना? Because
Yes, sir.
if we have phi, we can easily calculate delta lambda. What is delta lambda? H upon m naught c 1 minus cos phi. And what is delta lambda? Lambda dash minus lambda is h upon m naught c, 1 minus cos phi. So we can easily write lambda dash is equal to lambda plus delta lambda. We can find delta lambda from the mother equation and we can put it here. कर सकते ना? So now you can see we can get the relationship. We can get the relationship between theta and phi. And what is this relationship? The relationship is tan theta is equal to sin phi by lambda plus lambda dash by lambda minus cos phi. So you can remember as a formula or you can use it as a problem. So here is relationship between theta and phi, isn't it? Here is relationship between theta and phi. And if we can get the value of delta lambda, because we can get the value of phi, we can easily calculate this thing. Okay. Everyone is comfortable? Okay. So let's go for second problem. यहाँ तक clear है?
Yes, sir.
Yes, sir.
Okay, good. So you have to prepare all this thing, है ना? Questions are very simple, just straightforward question, but you have to prepare it. Okay. Now, let us go for our next problem. This is also sort of derivation sort of thing. And this is in term of energy. Okay. And then we will create one very nice problem. So suppose E naught is incoming energy of X-ray. Incoming energy of X-ray. Prove that energy of scattered wave or scattered photon, energy of scattered ray is given by E, which is equal to E naught by 1 plus alpha and just a minute. Alpha 1 minus cos phi, where alpha is E naught by mc square, okay, or m naught c square, where alpha is given by E naught by m naught c square. Now, so this is my A part of question. Okay, this is my A part. By using this relationship, just go for B part of problem. And what is this B part of problem? So there is incoming energy, incoming radiation is there, and it has energy E naught. It will just strike to the free electron of mass m naught and scattered into 90-degree angle. And after then, it will again strike to the free electron, another free electron, and again strike to the 90-degree. Okay, so there are two consecutive Compton effect is there. Are you getting my point? What there is two consecutive Compton effect is there at the angle 90-degree. कितने angle पर हो रहा है? 90-degree. So this is all about the 90-degree. So you have to just calculate energy of final photon. What will be energy of final photon? You have to use this thing and you can get this answer. Okay. So first one is very trivial. There is not any problem. Clear है? Problem समझ में आ रहा है?
सर बी क्वेश्चन एक बार रिपीट कर दीजिए.
बी में बता रहा हूँ. X-ray is coming with energy E naught, which is just going to collide to the electron. Okay. And after the collision, it will go into 90-degree. Okay. And in the path, there is another free electron. And again, it is going to scattered with this free electron at the angle 90 degree. So there are two successive collision at the angle of 90 degree. So what will be the final energy of this second scattered photon? So this is basically third one. So this is incoming, first one, second one, and third one. So what will be energy of this third one? Are you getting my point? समझ में आ रहा है? Let us first go to this problem. First, इसे जब तक derive नहीं करेंगे, it is very difficult to do this thing. So in general case, we will derive it and we can use it as a formula. So you can use it as a formula. Okay? आप इसे बहुत ही easily formula की तरह use कर सकते हो. So what will happen? It's a very interesting. We have lambda dash minus lambda is equal to h upon m naught c 1 minus cos phi. This is my mother equation. Every question will start from there. Don't worry. Okay? Every question will start from there. Now, what is going to happen? Can we write in term of energy? लिख सकते हैं ना? So how you will write it? I am just multiplying by h and dividing hc, and we are writing hc. So what will here? We have to again go h, and this will be c square. Can I do this thing? So what is this value? 1 upon e dash minus 1 upon e is equal to this h, and this h is cancel out. So what you will get? 1 upon m naught c square 1 minus cos phi. And we have to calculate e dash. This is basically e dash, you can write. This is my e dash. So 1 upon e dash is equal to 1 by e plus 1 upon m naught c square 1 minus cos phi. So you can just go for this particular equation. We can simplify this thing. So what will be this value? M naught c square plus e, isn't it? E into 1 minus cos phi, and by e into m naught c square, and that value is 1 upon e dash. Clear है ये value? Everyone is comfortable?
Yes, sir.
Okay.
Yes, sir.
Good. It's a very nice derivation. बहुत ही interesting derivation और बहुत काम की formula है ये. So let me clear this thing, then we will solve it finally, and then we will go for second problem. है ना? Okay. So what we have, we can write e dash is equal to e into m naught c square upon m naught c square plus e 1 minus cos phi. What we can do? We can just divide by m naught c square on both sides, on numerator and denominator. So you will get in term of energy by 1 plus e upon m naught c square 1 minus cos phi. And what is this value? ये value क्या है? This value is alpha. This value is identified as alpha. So you can remember e upon 1 plus alpha 1 minus cos phi. And what is E? E क्या है? What is E? Energy of incoming X-ray, isn't it? This is energy of incoming X-ray, and this is basically energy. This is angle of scattering of X-ray. Okay, and you can get easily what will be the energy of scattered X-ray. So you can directly use this particular thing without using SC, lambda, and all this thing into your calculation. Let us go for second question. I am interested more and more in second question. First one you can just take as a derivation. Okay, so let's try to go for what? Second question. What is going to happen? Look at here. यहाँ तक clear है ना? मैं सारे को हटाऊं क्या?
Yes, sir.
Okay.
Yes, sir.
Okay. Look at here. अब जरा देखते हैं. So this is my first wave or first X-ray. This is my second X-ray and this is my third X-ray. I have to calculate energy of first, second X-ray. So what will be second X-ray energy? I can write this thing as, let's say I am using this space first. Let's say its energy is E1. So what will be E1? Batao from this formula. E0 is the incoming energy by 1 plus E0 by M0 C square 1 minus, and what is value of phi?
90 degree.
90 degrees. So this value is 0.
0.
Okay. So this value is equal to E0 1 plus alpha. Are you people comfortable?
Yes, sir.
Yes,
है
sir.
ना? So this value
Yes, sir.
is E0 1 plus alpha. Obviously this is 1 plus alpha. That means E1 is less than E0. है ना?
Yes, sir.
Okay. Now take your time. So I have written energy of this one. है ना? This one has energy E0 1 plus alpha. What will happen? This is coming with energy E0 and it is scattered at the 90 degree. So it will go with the energy E0 1 plus alpha. Are you people happy?
Yes, sir.
Now it is again going to scattered. So it is again going to scattered in a 90 degree. So what should be the formula? So let's go for E2. अब यहां पर E के जगह पर क्या पुट करना है? E0 पुट करना है या फिर E1 पुट करना है?
E1, sir.
E1 put karna hai. Very good. So you have to put what? E1 here.
E1.
So you have to put E1 here and you will go for 1 plus E1 by, not alpha, that will be different thing.
Yes, sir. Yes, sir. Yes, sir.
M0 C
Got it.
square, again 1 minus, what is angle phi? 90 degree. है ना? Second time भी
Yes,
किस angle से जा रहा है? This is all about the 90 degree. So 1 minus 0. So what is this value? This value is equal to E1 1 plus E1 by M0 C square. Now I can put the value of E1. What is value of E1? E1 is equal to E0 1 plus alpha by 1 plus E0 upon 1 plus alpha, and there is what? M0 C square. ये दिखाई दे रहा है आपको? नीचे
Yes, sir.
यहाँ पर दिखाई दे रहा है ना?
मुझे राइट साइड नहीं दिखा दे सर.
राइट साइड नहीं दिखाई दे रहा है, इधर वाला.
नहीं सर.
ओके,
Yes, sir.
अब दिखाई दे रहा है? जस्ट देख लो.
Yes, sir.
अब दिखाई दे रहा
Yes, sir.
है ना?
Yes, sir.
Yes, sir.
ये तो थोड़ा एडजस्टमेंट करना ही पड़ता है ऑनलाइन में. आर यू गेटिंग माय पॉइंट? एंड व्हाट इज
Yes, sir.
E0 by M0 C square? Alpha.
Alpha.
E0 by M0
Yes,
C
sir.
square is alpha. Very
Alpha.
good. So what is E1? E1 is equal to E0 by 1 plus alpha by 1 plus alpha by 1 plus alpha. है ना? And what is your E1? Your E1 is equal to, sorry, E1 लिखे, E2 है ना? This is your E2. This is your E2. This is your E2 and this is your E2. And this is E0 by 1 plus alpha, और यहां पर 1 plus alpha आ जाएगा, क्या हो जाएगा? 1 plus 2 alpha by 1 plus alpha. This and this will cancel out. What you will get? You will get E2 is equal to, क्या आ रहा है? ठीक लिखा हो ना? या कुछ गड़बड़ कर दिया हूं?
सर ठीक है सर.
ठीक है. Yes. So E2 is equal to basically E0 and by
1 plus 2 alpha.
plus 2 alpha. So this is your energy. Look at how beautiful this answer is. है ना?
Yes, sir.
और इसी में आपसे पूछ सकता है how much energy the incoming wave lose आफ्टर द फाइनल स्कैटरिंग. सो क्या करेंगे, ई नॉट से इसको घटा दोगे,
Divide
इजंट इट, घटा
Yes,
देंगे,
sir.
है ना. यू विल जस्ट subtract with
Yes.
e naught and you will get this answer. So this is very new problem I have find in some book. So I thought कि भाई फॉर्मूला वाले तो सारे लोग करते ही रहते हैं, let us try to go for some more beautiful
Yes, sir.
problem, है ना. So we have done actually
Yes, sir.
two problems, isn't it,
Yes, sir.
है ना. So we have two problem and you can see how this thing is going to change. You can go for 3, you can go for 4, just try to do this thing, है ना. But angle is very important. If you will take another angle, then the another kind of answer will be there. ठीक है?
Yes, sir.
Okay. Now let's go for one more very fundamental question. ठीक है? And every time you will have exactly same type of question in your exam. Okay? Once I will do all this, just explain each and everything. Just go to your practice set and you are able to do each and every problem. Okay? Chalo. Now let's go for a very nice problem. It's a very fundamental and very nice problem. So, wavelength of X-ray, and this is wavelength is, let me check this number actually. Yes, the wavelength of incoming X-ray is H upon 2 m naught C, where m naught is what? Mass of electron. So we can write any wavelength in term of mass. Okay, so this is the wavelength associated with the incoming X-ray or what the radiation. And this X-ray is just going to back scattered. So this is coming into this direction. What is meaning of back scattered?
500.
Theta equal to pi.
Okay, so that will go into this direction, isn't it?
Yes, sir.
So phi is equal to what? Pi. Phi is equal to pi. Okay. My first question is very simple. What will be delta lambda? My second question. Find the wavelength of scattered radiation. Scattered radiation. Okay. My third question. इसी क्वेश्चन से हम सारे प्रॉब्लम कर लेंगे जो आपके एग्जाम में है. My third question. Find the kinetic energy of electron. Find the kinetic energy of electron. Okay. My fourth question. Find the momentum of recoil electron. My fifth question. इससे ज्यादा तो नहीं आएगा ना और कुछ? हाँ? Find the angle at which electron is going to recoil. Electron is recoil. Okay, everything we can cover into this problem. Yes or no? है ना?
Yes,
देख लो
sir.
जरा एक
Yes,
बार
sir.
ध्यान से. Everything we are able to cover. Okay, चलो. So first question, find the wavelength of scattered radiation. So which formula we are going to use? we will just use the mother equation. I am telling it, this is the mother equation of Compton effect. So that is what? H upon m naught C 1 minus cos phi. What is value of phi? What is
Pi.
value of phi? Pi.
Pi.
So what is delta lambda? Delta lambda is equal to,
2h by m naught c.
तो पहले तो डेल्टा लैम्डा निकालना था. So that will be 2h upon m naught c. Now
M naught C.
here I can discuss one particular theory also, that delta lambda will independent of wavelength of incoming radiation. Are you people convinced with this thing?
Yes, sir.
Delta lambda is not dependent which type, which wavelength the incoming radiation has, which wavelength. क्या उसकी wavelength है, वो delta lambda को कुछ भी लेना देना
Scattering
नहीं.
angle पे depend करता है.
That will only depend on the scattering angle and the mass of the particle
Yes.
at which this is going to scatter. Okay.
Yes, sir.
Okay. Here I can also discuss one particular thing. If I will increase the value of m naught, then delta lambda will be
Decreasing.
decreasing.
Decrease.
So for bigger m naught, suppose we are talking about molecules, or we are talking about some dust particle, or we are talking about some bigger mass, this Compton effect is not visible. Okay.
Yes, sir.
And even if it is bounded, suppose it is very highly bounded, then also this Compton effect is not visible, isn't it? Because if something is bounded, this m naught can be identified as infinite mass. Okay.
Yes, sir.
So why here electron in this particular experiment, the electron is very loosely bounded and the energy of incoming radiation is very high with respect to electron. So why we can say this electron is more or less free. Are you people agreed?
Yes, sir.
ओके. सो ये सारे ऑब्जेक्टिव में आएंगे क्वेश्चन, है ना, मोर देन वन वाले के लिए. ठीक है. बाद में हम लोग एक बार ट्रू एंड फॉल्स भी करेंगे आज, है ना. सो फॉर द दिस पर्टिकुलर थिंग MSQ. ओके, गुड. सो नाउ फर्स्ट क्वेश्चन आई हैव डन. सो दिस इज नॉट डिपेंडेंट ऑन व्हाट इज दिस पर्टिकुलर लैम्डा, बट व्हाट इज डेल्टा लैम्डा? Delta lambda is lambda dash minus lambda, and that is 2h upon m naught c. So what is lambda dash? So lambda dash is equal to 2h upon m naught c plus lambda, and this value is equal to 2h upon m naught c. And what is given value of lambda? H upon 2 m naught c. Yes. Are you people comfortable? What is this value?
Yes, sir.
What is this value? कितना आ रहा है? 5 upon 2 ना? So that value is 5h upon 2 m naught c. सही कैलकुलेशन किया हूं? देख लो भाई, मेरी कैलकुलेशन बहुत गड़बड़ है ना?
सर ये करेक्ट सर.
सही किया हो ना? आप अभी साथ साथ करते रहना, अदरवाइज हम लोग का गलत आंसर आ जाएगा. ये मत सोचना है कि मेरे पास सब लिखा हुआ है. ठीक है, मैं देख करके लिख ही नहीं पाता हूं, है ना. चलो, अब तीसरा क्वेश्चन क्या लिखना है भाई? व्हाट इज माय थर्ड क्वेश्चन? वी हैव टू फाइंड द काइनेटिक एनर्जी ऑफ रिकॉइल इलेक्ट्रॉन. सो व्हाट विल बी काइनेटिक एनर्जी ऑफ रिकॉइल इलेक्ट्रॉन? एनीबॉडी?
सर hc by lambda minus hc by lambda.
Very good. This is incoming energy, hc upon lambda minus hc upon lambda dash. So you can just put, what is lambda? hc upon lambda. Lambda is what? h upon 2 m naught c. ठीक है ना? Minus hc upon, what is lambda dash? Lambda dash is something
5h by 2
5h upon 2
m naught.
m naught c. Clear है ये? So this can be written as, नीचे वाला भी हटाना पड़ेगा. So this can be given by h and h will cancel. You have 2 m naught c square minus, what is this? 2 by 5 m naught c square. This is your kinetic energy of what? Electron. This is kinetic energy of electron. ये सबसे ज्यादा इंपॉर्टेंट क्वेश्चन है आपके एग्जाम का, है ना? इफ यू विल
Yes,
सी
sir.
द 10 क्वेश्चन ऑफ जैम एग्जाम, out of this 10 question, 8 question they are asking what is the kinetic energy of electron, what is the momentum of electron. Okay,
Yes, sir.
and because everything can be used into this particular problem. So ये कितना हो जाएगा भाई? 8/5 है ना?
Yes, sir. 8/5. Yeah.
8/5 m naught c square. So this is your kinetic energy of electron. And look at rest mass energy of electron is m naught c square. This is 8/5. What is the meaning of that? Meaning of that, the electron is moving, because moving mass appears heavier in the STR,
Yes, sir.
है ना? Special theory of relativity. So there will be some momentum. So now let's try to go for the momentum. How you will calculate the momentum?
Sir, E equals P by P into C. P was
Very
critical length.
no. You will calculate the kinetic energy of recoil electron is equal
Yes.
to P square C square m naught square C4. This is your total energy of electron minus
Yes, sir.
rest mass energy of electron, है ना? And you have kinetic energy. What is your kinetic energy? 8/5
8/5.
m naught C square is equal to P square C square m naught square C4 minus m naught C square. You can take it in this side. What will be this value? 13/5 m naught C square. ठीक लिखा हूं? So this value is P square C square
Yes, sir.
m naught square C4. Okay, good. Now this is root under. Now what we will do? We will take the root on both sides and we can get the answer. ठीक है? So that is what? 13 square by 5 square minus 1 into m naught square C4 is equal to P square C square. सही लिखा हूं ना?
Yes,
स्क्वायर
sir.
किया, इसको इधर ले लिया, ऐसा जानबूझकर लिखा है. Pythagoras law, remember? 13 square
Yes, sir.
minus 5 square is what? 12 square by 5 square m naught square C4 is equal to P square C square. So what will be your P? What is your momentum? So momentum is 12/5 m naught C. Wow, what answer, है ना? हो गया ये? Now
Yes, sir.
next हमें क्या करना है? We have to calculate the angle of recoil. Okay, what we have to calculate? The angle of
Angle of
recoil.
recoil.
So how you will calculate angle of recoil? You have formula, remember? अभी तुरंत करवाया था.
Yes, sir.
चलो बताओ क्या था formula? Tan theta is equal to
Sin phi
tan
by
theta is equal to sin phi by
delta
lambda plus delta lambda by
by
lambda
minus cos phi.
minus cos phi. Okay, so obviously phi is what?
Sin pi 0.
Phi.
Phi.
So tan theta is equal to 0. इसकी कोई जरूरत ही नहीं पड़ रही है ना? So tan theta is equal to 0. So theta is equal to 0. So what will happen? This is incoming in this direction. The photon will go into this direction and electron will recoil into this direction, isn't it?
Yes, sir.
Because that momentum can be easily conserved. So obviously you can use all this formula and you can easily discuss the thing. Okay, so you have to always keep in mind the mother equation is all about delta lambda. Once you will get the delta lambda, you can easily calculate each and everything, isn't it? And delta lambda is mainly dependent on what? Scattering angle and the mass of particle at which the thing is going to scattered. Okay,
Yes, sir.
Sir,
बताओ.
वो tan theta कैसे zero हो गई? Can you repeat?
Tan theta कैसे?
Zero हो गई.
Because phi is equal to pi. Okay,
Okay, sir. Okay, sir.
because it is given na, that is back scattered, so phi is pi, so tan theta is 0. nahi?
Okay, sir.
Okay, good. So let's try to go for little bit of true and false. Okay, ट्रू एंड फॉल्स के लिए बात करेंगे, ठीक है। और जिस स्टूडेंट का नाम लूंगा मैं, वो स्टूडेंट्स बात बोलेगा क्या होगा आंसर। सो लेट मी टेक योर नेम। ओके, सो अंजू, just tell me, Compton effect is justifying wave nature of light, true or false? Just tell me true or false.
False, sir.
False.
Proves
Very good.
particle nature.
That is basically particle nature. Okay, good. Karthik, just tell me
Yes, sir.
that delta lambda is independent of incoming wavelength of the radiation. True or false? Delta lambda is independent of incoming wavelength of radiation. True or false?
True, sir. True.
This is true. Okay, so that will dependent on only scattering angle. Okay.
Yes, sir.
Okay, now next, Tirtha, now you can just tell me, if for the fixed value of phi, if mass of a particle will increase, then delta lambda will increase or decrease, or remain same?
If mass increases, delta lambda decreases.
Very good. Delta lambda will decreases. Okay, good, very good. Now, so these are the, and the delta lambda is maximum for what angle?
Phi.
Very good. Shekhar, बताओ, delta lambda is maximum for what angle? Shekhar,
Yes, sir.
what is delta lambda will be maximum for what angle?
80 degree.
Maximum delta lambda maximum. Any another person? Delta lambda will maximum for what angle? Chanchur?
Phi.
Phi. And minimum for what angle? Minimum
Zero.
for what angle? 0. So there is not any peak at the 0. Both the peak will merge. Okay. Okay. So I think these are the basic thing you have to always keep in mind. Now just tell me, here the energy difference between incoming radiation and scattered radiation is exactly equal to recoil kinetic energy of electron. True or false?
True, sir.
True. The energy difference between incoming radiation and scattered radiation is equal to total energy of electron. True or false?
False.
False.
True.
Very good.
False,
False.
sir,
False. They are equal to what? Kinetic energy of
Kinetic
electron. है ना? ये आप ध्यान में रखोगे. Okay? Okay.
Yes, sir.
The Compton effect is equivalent to elastic collision of two particles. True or false?
False.
True.
True.
Elastic collision
Yeah,
means what is going to happen? Conservation of momentum is there and conservation of
Yes.
energy is also there. Okay?
Yes.
Okay? So this is something like elastic collision. You can assume that two particles are doing elastic collision here. Okay? So these are the things you have to keep in mind. Okay? And finally, you should go to your first chapter, that is particle nature of light or light, and this thing we have covered. In next week, we will go for wave nature of particle. Okay?
Yes.
Just
Yes,
cover
sir.
all this. Tomorrow you have some break, so you should cover all the problem. ठीक है?
Yes, sir.
Okay. चलो, अगर कोई डाउट हो, you can just post me on your WhatsApp group, or you can send it to the Satish sir. We will arrange our doubt classes also. Okay?
Okay, sir.
Okay, sir.
Okay. Chalo. And there are a lot of problem. So first, what you will do? Just go to PYQ, previous year questions. Okay? And after then, you can go for the worksheet. Okay?
Okay, sir.
चलो फिनिश करो इसको फटाफट. वी हैव टेस्ट ऑल्सो, है ना?
तो टेस्ट कब है सर?
आपको बताया नहीं जाएगा, चैप्टर खत्म होने के बाद कभी भी हो सकता है. ओके,
ठीक है सर, ठीक है.
इट मे बी टुमारो ऑल्सो, डोंट वरी.
ओके सर, ओके.
ओके ओके, चलो आगे बढ़ते हैं, है ना? थैंक यू.
या ओके सर.
Thank you, sir.